Hello, so in today's video, we're going to look at the sine rule. So this is again a rule that you may have seen before. So the sine rule says that if you have a triangle with an angle A there, an angle B there, an angle C there, and if you call the opposite sides to these angles the lowercase versions of those letters, so A there, lowercase a is opposite to the capital A there, lowercase b is opposite to the capital B there, and lowercase c over here is opposite to the capital B, sorry, capital C angle there. um, the rule goes that a lowercase a, the side, divided by sine of capital A is equal to b lowercase b divided by sine of the angle B, and that's also equal to c over the sine of this capital angle C. So that's just like how the sine rule works. Is a formula. It's a formula of these ratios there, and it basically says that these ratios are all the same. So how could we prove this rule? So we're going to draw our triangle again, ABC. We're going to label our opposite sides the lowercase version, so A over there, C over there, B there. So what you can draw is you can draw in a right angle triangle like this. You can just split. You go to this vertex there, draw a dashed line down here, and now you've got two right angle triangles. You've got one on the left here, this AB side, and then this CB side. You've got this right angle there. So let's think about this height. I've called this height here H, capital H, our height. So let's think about this. We've got an angle there of A. That's our angle A. So we know that sine is opposite divided by hypotenuse. So sine A is going to be the opposite to this A, this right angle triangle, remember, because we're dealing with the right angle triangle when we use SOHCAHTOA. So the opposite side to this A is going to be H. And then we want to divide that by the hypotenuse of this left-hand side right angle triangle. We're going to get C. So sine A equals H over C. Now, if we just times both sides by C, we get C is times by sine A is equal to this height, this capital H. Okay, so we're just going to keep this in mind. I'm going to just underline that. Now let's go to triangle. If I call this one triangle one, so this is triangle number one. Now let's focus on triangle number two. So triangle number two, this one here, this right angle triangle. So opposite the angle C, we've got H. So sine of C is going to be the opposite side, this height, the height H, divided by the hypotenuse, which is A in this case. So A there. Okay, so now then, if we times both sides by A, sorry, let me just make the C a little bit more lowercase, just to make it clear that this is a length there, lowercase c. Times both sides by A, we get A times sine C is equal to H. So we get this equation there. Now we've got two formulas for H. We've got this formula there and that formula there. They're both, well, H is obviously equal to H. So that means that C sine A is equal to A sine C. So if we just, again, keep this all on the same page. So therefore we know that, so therefore A times sine C is equal to C times sine A. So now what we can do is divide both sides by sine A to get A sine C divided by sine A equals lowercase c. And so therefore we get, if we divide both sides by sine C, we get A over sine A is equal to C over sine C. So we know that those ratios must be the same. Now we can continue and do another example similar to what we did here, involving the B this time. So again, I'm going to draw exactly the same triangle like this. C there, capital A, capital C, capital B, lowercase b, and a lowercase a there. So now what I'm going to do instead this time is I'm going to draw a line there, and now I'm going to call this line L. So I mean, let me actually try and draw that line a bit neater, actually, to make it look like a right angle. What I'm trying to do is I'm trying to make a right angle triangle here. So this becomes a right angle triangle, and this becomes a right angle triangle. So I'm going to call this length L. So this length L, again, we can use SOHCAHTOA. So if we look at the sine C down here, so sine C, sine is opposite over hypotenuse. So the opposite side in this right angle triangle, I'll call it right angle triangle A. So for right angle triangle A, opposite the C is this L. and divide that by the hypotenuse, which is this b here. So b is the hypotenuse. So we can times both sides by b. We get b times sine c is equal to L. Now, if we look at triangle B over here, I mean, this probably wasn't a good idea to call it A. Let me just call it capital X. So triangle capital X, this one here, and this is triangle capital Y here. So for triangle capital Y, we've got, again, an angle B there. So sine of the angle B is opposite over hypotenuse. Now, the opposite, again, is this length L. This opposite side to the angle there is L. Divide by the hypotenuse. Hypotenuse is C, lowercase c. So that means if we times both sides by C, we get C times sine B is equal to L. So now we've got, again, two equations for L, two formulas for L. So what that means is that we can just put them equal to each other, just equate the two expressions. So therefore, B sine capital C is equal to C sine capital B. So therefore, divide both sides by sine B. We get B times sine C divided by sine B is equal to C. And lastly, divide both sides by, by the sine C. We get B divided by sine B is equal to C divided by sine C. But we know that C divided by sine C is the same as A divided by sine C. So this is also equal to A divided by sine C. And so now we've proved the result because, yeah, all three of these ratios must be exactly the same. So, yeah, therefore we prove the result. And therefore A over sine A equals B over sine B, which equals C over sine C. So, yeah, so that's our sine rule. So, again, it's just a summary. So the sine rule says that A over sine A equals B over sine B, which equals C over sine C. You may also see it written like this as well. So there's an equivalent way you could write this. I mean, if you just flip all of the fractions upside down, you get sine A over A is equal to sine B over B, which is equal to sine C over C. This is exactly the same. It's exactly the same equation. They're exactly identical. Well, not identical equations, but they're equivalent equations. They're equivalent. And again, this is when you have a triangle, any triangle, with an A there, B there, capital B angle there, C there, lowercase b, lowercase a, lowercase c. So this is how the sine rule works.